Hello everyone, my name is Ashley Goodnight and this is my Reading Week 13 video. This week, we continued our discussion of angular momentum principle. Specifically, we took a look at the angular momentum principle applied to a multi-particle system. We found that in a system of multiple objects, we can sum the individual angular momentum quantities to find L total. Also in this week's lectures, we analyzed the torque of a multi-particle system. The videos explained that torque is similar to Newton's second law that stated the sum of the internal forces in a multi-particle system cancel out. We learned that internal torques cancel pairwise. Therefore, the net torque depends solely on interactions with the surroundings. In my previous high school physics class, we covered a small portion of angular momentum. However, this week's video lectures covered almost completely new information. We discussed that the angular momentum of a multi-particle system can be decomposed into two parts, translational angular momentum and rotational angular momentum. The translational aspect deals with the angular momentum if we treat the system as a point mass located at the system center of mass. The rotational aspect deals with the angular momentum relative to the system center of mass. Another main topic we discussed this week was rigid motion. The video defined rigid motion as when all particles are locked together and move as a plane. In general, in the special cases of rigid motion, rotational linear momentum is equal to I times omega, the inertia times the angular velocity. Note that the direction of the angular velocity is the same as the direction of the angular momentum. This concept of rigid motion was completely new to me, so I went onto Google and found an article by Lumen under the Boundless Physics section. The page titled Conservation of Angular Momentum was expertly organized and included definitions, key points, and useful diagrams. My major, electrical engineering, has another right-hand rule similar to determining the direction of torque and angular momentum. With electric fields, use the right-hand rule to help remember the direction of magnetic forces. If you point your pointer finger in the direction of the positive charge, then your middle finger in the direction of the magnetic field, your thumb points in the direction of the magnetic force pushing on the moving charge. When you're dealing with negative charges like moving electrons, the force points in the opposite direction as your thumb. With that, I am concluding my presentation. Thank you everyone for listening. See you all next week.